Hello friends, in this video we are going to discuss about derivative of power of x. Okay, so first we have y equals to c, or a constant function. Let's see how we can calculate the derivative of a constant function, derivative of y equals to a equals to x power 1, or y equals to x power 2, or y equals to x power 3. So let's see how this can be demonstrated. So first we start with a, where y equals to c, constant function. Right. Okay, so first we have let's draw some graph here. Yes. Okay, so as we see, the graph of y equals to c is a straight line parallel to the x-axis. Therefore its gradient would be equal to 0. So let's assume the point c here, point c. So the line y equals to x would be equal to, here on the graph, as will be drawn like this. Will be drawn like this. Y equals to c, right? Here we have y, here we have x, right? So okay, as we have seen, if we have a point c, point p here as initial point, and also another point here, let's call it R, and if we have another point here, point Q, and also another point here, let's call it S. Okay, so we can say that the distance RS, because here it is an x-axis, distance RS would be equal to change in y, no, change in x. Yes, because this distance is given by AC minus R. Okay, so it gives change in x. Okay, maybe we can also denote this R as x0 and also AC as x, so that this distance would be equal to x minus x0. Yes, also as you can see here, the point P, if the point P is pointed as y0, also the point Q will be y0, so that it means that there is no change in y. Okay, if there is no change in y, it means that y0 minus y0 would be equal to 0. So that means dy, change in y, would be equal to 0, right? So as you can see here, as you can see, since y equals to c, and you have seen that from the graph dy equals to 0. Okay, because there is no change in y. Okay, so if y changed would be or would give the value equals to 0. Also we have also see that ds can be equal to s minus r, or simply x minus x0, so that can be changed in x. Okay, so that will be, this will mean that dy over dx would be equal to 0, because dy equals to 0 over dx. Okay, and this would give 0. So as a conclusion, the derivative of constant function equals to 0. Derivative of constant function equals to 0, right? That is the conclusion. So any derivative of constant function would give 0. Okay, so let's take another example B. We are given y equals to ax. So let's draw this graph here. Another graph for this one. Okay, yes, here we have y and here we have x. Okay, so approximately the line will pass through the origin. Okay, so the y equals to ax, right? So here, as you can see, if the y changes, also x will change. If y increased by, if y is increased by change in y, also x will be increased, x will be increased by also change in x. Okay, that means the change in y or increase in y would be equal to, a x plus a change in x, right? So that we have y plus change in y equals to ax plus a times change in x. Okay, so subtract y on both sides, you will get y minus y plus change in y. This would be equal to, because y equals to ax, also here we'll have ax minus ax, then plus a change in change in x, right? So here we have y minus y equals to 0, so we remain with change in y equals to ax minus ax equals to 0. So also we'll have a times change in x. Okay, so as you can see here, a would be equal to change in y over change in x. So if change in x approaches 0, the change in y over change in x right, would give dy dx. So that means if change in x approach 0, the derivative of y equals to ax would be equal to dy over dx, which is equal to a. Okay, that is what it means. So let's see another example, number C, where y is equal to x power 3, right? So I think I jumped the number. It is x power 2, right? It is x power 2, yes. Also, let's draw the graph that shows this clear graph. Okay, as you can see here, y equals to x power 2, so the graph of this function will be quadratic curve. Okay, so here we have origin y x. Okay, so let's estimate that this is the distance from origin. Let's call this distance x0, and also from this distance from here to here, let's call it x. Okay, from origin to x here, and from here to here, this is x0. Also, let's take it this as y0 and here as y, right? Okay, so I think you see the point here, point x, and so let's x put here so that it will be meet with this one. Okay, and this one will be meet this one at this point. Okay, so as you can see here, we have a distance. This distance will be equal to change in x, and also from here to here it will be equal to change in y, right? So here the graph is equal to x squared, right? So okay, let's call this point P, and this point, let's call it Q. Okay, so as we see at Q here, from here up to here, y is equal to from here up to here, we will get y plus change in y equals to this one. From here up to here, it would be x plus change in x, then squared. Okay, so we know that from here, we know that we have a complete square here, where we know that there is a formula that states that a plus b squared equals to a squared plus 2ab plus b squared. So simply that is what we are going to apply here. So this means that y plus change in y will be equal to x squared plus 2x change in x, okay, plus change in x squared, right? Okay, right. So as we know, y equals to x squared. So if we take y minus y here plus change in y, this would be equal to x minus x, which is squared, plus 2 times x change in x, okay, then plus change in x squared. Okay, so we remain with the change in y, which is equal to 2x plus 2x times change in x, okay, times change in x plus change in x squared. Okay, we see, and this would be divide change in x on both sides. We'll get change in y over change in x, which is equal to 2x plus a change in x. Okay, that's it. So if change in x approaches 0, is decreased so that it approaches 0, this means that change in y over change in x, right? Change in x would approach dy dx. Okay, so that means the equation will become dy over dx, which is equal to 2x plus 0, because change in x is approaching 0 in this case. Okay, so this means that change in y over change in x is equal to 2x, right? So according to what we have seen from the demonstration of the first here, where y equals to ax, and according to this one C, where y equals to x power 2, we have seen that for any value of y, if y equals to x power n, this means that dy over dx would be equal to, you have to take n here as you have taken 2 here, okay? You have to take the power n here, then times x power n, then minus 1. So simply, that is the general formula for the polynomial derivative of polynomial function. Okay, so this means that number D we have seen where y equals to x power 3. So this means that y change in y or dy dx would be equal to, you have to take here, we have n equal to 3, so we have to write n as 3, then times x, then 3 minus 1. Okay, so the answer would be 3 times x squared. So that is the result. So simply this is how we can calculate the derivative of a polynomial function, or the derivative of power of x. So thank you for watching this video. If you are new here on this channel, make sure that you have made subscribe and share so that you will be the first one to see the video after being uploaded. Thank you.